Hey, all right, what's going on? Yeah. God damn. All right, let me try that again. Jesus. All right, what's going on? So this is kind of the introduction. All right, damn, man. Bring it back. Hey, what's going on? So this is going to be the intro video for this channel, Taught Not Brought, where basically I'm just going to be exploring different subjects that I like, whether it be math, science, engineering, political stuff, environmental stuff, basically anything that catches my attention and I want to study further in depth. That's what this channel is going to be for, just for me to keep track of what I've learned, what questions I've had, where I got stuck in the past, and maybe going through some of this stuff, it'll be resources that other people are trying to find solutions for also. So hopefully I can help out a little bit there. But in today's, we're going to be looking at lean. So I've been thinking about lean for a long time. If you don't know what lean is, basically it's a programming language that allows you to do general programming, but it also allows you to do things like proof assistance, like math proofs, automatic theorem proving. Basically, it's a tool, it's a programming tool where you can program math and have it check everything for you. There's more that you can do than that. And I'm really trying to learn more about the functional programming aspect of it. More like the bare bones stuff, because I feel like there's already a lot of resources out there for the math sections. But I just want to increase the knowledge that I have on how this language works, and see how I can use it. And hopefully, if I get a good grasp on it, I can use it for some real math later on in other videos, where we'll be going through different areas like probability, calculus, differential equations, that sort of thing. And hopefully using lean as a tool, not just to prove theorems, but as a tool to assist in the learning process. Hopefully learning how to formalize all of this mathematics will help me be better at understanding and bringing up the mathematics when it's necessary. But yeah, so basically today I'm just gonna try to get as far as I can and these as possible. I started maybe 3 months ago, and I got down to I finished this one, so polymorphism, and let's see, there's 10 chapters. Um, I'm not about to count how many sub chapters there are all together, but if anybody else wants to do that, the numbers are right there. Um, but yeah, so I didn't get super far in it. Almost finished the first section. The part I really want to get to, funnily enough, is the second section, the Hello World, where you actually learn more of the functional programming aspect of it. You learn like inputs, outputs, and how to deal with what will be called side effects in other functional programming languages. So yeah, so I guess just to get started, we're going to start at the top. I'm probably not going to read everything out loud, just because, like I said, I already did it. And if you want to read word by word, this is the website. Feel free to do it yourself if you are doing it. Please let me know. It's always fun to have somebody else who's working on the same thing. And, why do it alone when you can have more than one person thinking through a problem at the same time? So I guess just to scan some stuff. So it is a programming language. So what makes it different from others, and I'm not a programmer. I know like a little bit of Python, a little bit of R. I'm much better with R than Python, but I'm not like crazy with any of them. If you give me a cheat sheet, I might be able to put something together. You give me the documentation, I can make it work, but it might take a few hours. Uh, but yeah, so one of the things that makes it different, like I said, allegedly, because I'm not a programmer, is that most other programming languages have a read, evaluate, print loop, while Lean doesn't have that. Basically, when you're typing everything out, it's interactive. Like as soon as you finish the line that you're on, if it works, you'll get the right colors. And if it doesn't work, you won't get the right colors. You'll know immediately. And this will make more sense once we actually get into the language. So something I probably should have did beforehand. I'll let this open up in the background because when you have lean and you have it for VS Code, there's like a language server that has to come up. So it takes, I guess it really just depends on like how strong your system is and everything, but it takes like a minute or two before it's fully running. Um, and then, like I said, I already got sort of far in this. So this is where I was, exercises for chapter 1.6. And it's a bunch of stuff that I just like tried out to, try to get it to work. Um, but this was about 3 months ago, and really I just want to do a clean start, kind of start over. It wasn't super hard the first time. Hopefully it'll be much easier the second time, and I won't embarrass myself completely um, when everybody's watching me. I'm about to embarrass myself right now, to be honest with you, because I forgot how to create a new file. There we go. And then motherfucking there's a much easier way to do this. There's a much easier way to do this. How the fuck? All right. So already it's falling apart on me. What was this one? Basic lean. I don't think there was really anything in there. I might just use this because I don't feel like looking crazy right now. So we're just gonna get rid of that. Boom. And now we're in there. So yeah, once we get going, you'll see what I mean. Once you're typing stuff out, actually, let me just go back. Uh, I mean, that wouldn't tell you anything really. But yeah, once you start doing more, there will be information on this side that basically gives you clues on if you're doing it correctly or not. And this will be much easier on two screens, but as y'all can see, I'm out and about in the real world. And I did not bring a second monitor with me. I wouldn't even have anywhere to plug it in. But fuck it. Just gonna go back and forth. And hopefully that one curse word didn't fuck up my future monetization policies. That would be some ass. So yeah, reader, whatever. So basically, you're gonna use eval when you're actually evaluating a function. So they got some here where it's like, could have just pressed the copy button. Uh, the eval 1 plus 2, and I'm not even gonna copy paste that, to be honest. I'm just gonna type it out so that you can see when you're typing, when you are typing 1 plus 2. And over here you get 3. So if I don't have that, it says no info found. Um, if you evaluate one by itself, it's just 1. And so it has like most of the normal functions already built in, like addition, subtraction, division, exponentiation, all of that good stuff. Um, what was the next example? The next example was probably showing us order of operation stuff. So y'all know PEMDAS. I ain't gotta explain it to nobody. So if I did 1 plus 2 times 3, I'm gonna get, I don't want y'all to cheat. So 1 plus 2 times 3, what answer should you get from that? So obviously, if you're doing PEMDAS, multiplication, division is going to come before addition, subtraction. And we don't have any parentheses here, so the answer we should get is 3 times 2, which is 6, plus 1, which is 7. And that's the answer we got. So easy stuff, pretty simple. Y'all know how math works. Let's go to a different example. So here, this is actually something that's going to be important later. Trust and believe, because I fucked it up a couple of times. When you're doing this, so let's say you're doing a function like string append, and string append takes 2 arguments and puts them together. And in this example, it's a string. Well, it's appending two strings, um, which I guess now that I think about it, the append function, um, you're probably able to use more than string. Like you're probably able to use lists or sets or something, arrays. But in this particular example, you have to put in two strings. Bada bing, bada boom, you get what you're looking for. So let's go in here and do that and maybe fuck it up a few times to see what the wrong answer looks like. Let me just come up here, put the heading so I know where I'm at. And I think, yeah, two dashes, I'm gonna say chapter one. One, and what was that one? Evaluating expressions. So boom, if it you do evaluate, string append. Wow, dude. All right, so I hope the camera just caught that, but a bird just shit on my laptop, so we're gonna have to take us a quick intermission to clean this shit up. Right, we are back and better than ever. All right, where we at? So string append. So let's try to fuck this up. So, well, before I do that, let me take a step back. So with string append, with any function in lean, really, if you don't have to put the parentheses and the comma, any of that stuff, you just have to provide the two arguments right after the function. So instead of doing something like, let's say f motherfucking, let's say you have a function and it takes fucking A and B. I don't know why it took me so long to do that. Instead of writing it like that, you could just write F for the function, A for the first argument, B for the second one. So hopefully that makes sense. So that's what's going on here. String append takes two arguments. Fine. String append takes two arguments, and I provide the two hello and lean. So let's try to fuck that up. What happens if I take the commas out? So the second argument, it expects to be a string. So it's looking for a string and it doesn't get one. So I get this unknown identifier. Let's see, let's try that one. This is something you're going to get all the time. Please get very comfortable with this little error message right here. Could not synthesize a repr or two string instance. You're gonna see that a lot. And 90% of the time that I saw it when I was working up to chapter 1.6 was because I did not provide a second I didn't provide the argument that the function wanted. I wish there was a way for the function to just tell me that, like function expects second string or something like that. So there is like, you kind of have to figure it out when you look at this to see what's going on. Maybe there's something in here that is extremely helpful and I'm just missing it because I don't know. Um, but yeah, this where it says instance for type string to string, that doesn't really tell me anything. Let's see what happens if I take this one away. So then you take both away, it makes a little bit more sense. So let's think about what string append is doing. It's taking two strings, so two arguments, and it's giving you another string back. So this is telling you like what the function wants as inputs and what it gets back as outputs. So this honestly is another thing that's gonna piss you off a little bit because this looks helpful, but this could, honest to God, mean like four completely different functions. For instance, it could take a string and it could give you back two strings or something. You know what I mean? So there's no parentheses to tell you exactly what's going on. You kind of just have to figure out what that function is supposed to do, or if you made the function, hopefully you know what its arguments are, and what you should expect as outputs. But let's try this to the second one. So like I said, could not synthesize, it expects a second string, I didn't give it one. So this is basically telling you it needs another string to complete the inputs for the function. Helps to spell, helps to spell. So boom, everything's working as planned. So let's see what else they got for us. Order of operations for parentheses. We're just talking about parentheses. Uh, so let's do this one. Basically, what this one's trying to tell you, and I'll just write it out because when you're practicing this stuff, it's better to look at it, see what it needs, and try it yourself. So boom, the example, what was that? I'm gonna have to edit that out. Y'all can't be saying the secret sauce. So let's try eval, and I'm gonna do actually this exact same function that I did before, but a little bit differently. So I want to make a function where I can enter all three of these strings and just get one string out at the end. So what we're trying to do is something like string. So we're trying to get a function that looks like this. Wait, hold on. Once again, people, it helps to pay attention. That, there we go. So three strings, and then take those inputs and output a third string. And so let's break it down. String append can only take two arguments. So how can we break this down into three arguments? So what if instead of trying to put all three in at once because we can't, we just did two. So I actually didn't need to get rid of that arrow at all. It's falling apart, people. It is falling apart on me. There we go. String, get your parentheses straight. So instead of trying to do it with three inputs, and we can figure that out later. It's going to teach you how to make your own definitions and everything in a quick second. But let's look at this. So what we could do instead of putting all three in at a time is to do one string append where we take the two strings, get an output, and then we use that output as the second input for the next function. So let's try that out. We're going to do eval string append. And like I said, I don't know if it'll work like that. So it probably won't work. Let's try it out and see. So we're going to do string append taught. Then we're going to do another string and we're going to do not. And for the second argument, and since this is inside of parentheses, I do have to put the comma for it. But here, we're going to fuck this up on purpose because this isn't going to work. but we're going to figure out why it doesn't work together, because that's what it means to learn something, to understand why it didn't work. So, taught, not brought. We're going to put space in this. So, application type mismatch. Let's try to figure out what this error message is telling us, since we basically already know. So, application type mismatch. So, there's a mismatch in the type of input that this function is supposed to receive. Taught.append, I think that's the name that it's given this first function. String append argument. String append has type string, string, string to string as its type. So, like I said, string append expects 2 arguments and it gives you 1 string as an output. Or hold on, let me see. Maybe it's the other way around. I really don't know what this thing is trying to tell us. But let's do it the right way and see if that changes anything. So basically what's going wrong here? This string append needs 2 arguments, and it needs those arguments to be strings. The first one is a string, but the second one isn't a string. It's a function that isn't, because it hasn't evaluated yet, it doesn't give back a string. So let's go back. We're going to do this one here. And like I said, since this is in parentheses, it needs a comma. So let's see what we're getting now. What has changed in our argument? Not much. So string append. Yeah, let's see. We got to do another one here. Delete that. Like this. Taught. And then because it's inside of parentheses, I have to have the comma. And then there's a mismatch here because I don't have another parentheses to close out on the end. Let's see if that fixes it. And it does not. So now things are getting interesting. I thought I knew what was up. Let's look. String rate. Okay, all right, we're bringing it back out. So actually, I don't need it for this, but I do need it for this, so that it knows that. All right, now hold on, because this is pretty similar to what's on there. Because this is too close. There we go. There we go. So, yeah, you see what it's like. Let's try another one. Additional statements. So we got a if then else. Just gonna copy that and put it in there. Let's play around with it. Let's put that eval. So it gave us a it is no. So we can insert other functions. So let's see if we change this to false, like in the example. I'm not sure if that'll work. Yeah, because the statements 1 is greater than 2 just evaluates to false. So I guess that collapses down there. Okay, easy, easy. That's going to come in handy later. So I'm not going to do all of these by hand. Let's, I ain't going, that's a simple calculation and I can't add, so I ain't doing that one. So let's try this one out. String append A, string append B, C. So that one checks out. It has 2 arguments, A, and then a function that's contained right here in the parentheses. That's another string append, that it has 2 arguments, B and C. So string append should be string append A, B, C. And then this one, string append, this time the function is the first argument. It has 2 A, B, that should all be correct. And then C here, it should be the same thing, A, B, C. So let's try those out. Let's see if I'm as right as I think I am, or if I embarrass myself yet again. So ABC, and then we're gonna do another eval. Let's grab this other one. To Lord, to make it sure. Now let's see. Oh, dog right there. I wonder if we're able to do something like, let's do eval. If this is like an allowed thing there. Oh, yeah. So cool. We can use the equal sign to also evaluate, I guess, equality through functions. So boom, this one should be ABC, this one should be ABC. And so the strings should be equal to each other. So this should basically be the same thing as if I were to say, eval ABC is equal to, let's see, we get a true, unless if I change the ABD, we get a false. All right, cool. What else is on there? If 3 is equal to 3, then 5 else 7. So this should evaluate to 5, since that's the true statement. 3 is equal to 4, then equal, else not equal, and this should evaluate to not equal since 3 is not equal to 4. Um, and I wonder what the difference is between the single equal and the double equal. Because I'm used to the double equal being defined, being used for defined as. So maybe it's a little different. Maybe we could play around. Maybe it's the same thing once you get down to it. So boom, 5 like we expected. Let's see what happens if we take one of these out and it still works. Oh, hold on. Doesn't work? Yeah. Yeah, still doing the same thing. So it's a proposition if it's 1, but a Boolean if it's 2. We're gonna have to come back to that. So yeah, I think that basically does it for that first section. Let's move on to types. Types, all that stuff. Like I said, y'all can read this if you want to. I read it before, and I kind of remember what's going on. Uh, so this function here is basically when you're doing this, you're saying that this in front of it is of the type nat, which is for natural numbers. Um, positive and non-negative integers, I guess, if you want to include zero in there. Okay, so that's interesting. Um, so since in the natural numbers, of course, it goes 0, 1, 2, on and on and on. Since there are no negative numbers, if you try to subtract, it just goes 0 because that's the lowest number that it has. That's the lowest number in the nats. So let's try that out and see if we get 0 like we expect. Copy anyway. So yeah, you get 0. So yeah. And I guess it just automatically assumes what type of numbers they are. So let's do this. So 1 minus 2, we're gonna say natural numbers 0. But if we change it to an integer, which has negative numbers, then you do get -1. So we gotta watch those types. And then you can use check um, to check what the types are, and it seems like it gives you slightly better error messages. So let's go back to where we were. I should have kept the one that I messed up. Fuck it, I'll just mess it up again. So that's fucked up now. If I change this to check, let's see what happens. It's still not telling me much, but good to know anyway. Is that it for types? Okay. See functions and definitions. So def hello world is equal to the string hello. Finally get to some hello world out here. See what happens if I just do it. Type string, alright? Good. Like I said, the single equal is for equalities between expressions. So boom, here they're just defining the type. Let's try something. Let's try something and see if it works. So I'm gonna do def uh one, and that's gonna be for the naturals. It's gonna be type net. It's gonna be, let's see, the number one, and then we're gonna do def one I for integer, type int, also one, and let's see. Let's try to use the double. Let's see what happens. Because it should give me either a true false statement since it's a Boolean. And it is true. Okay, that's interesting. I have to come back to that one then. Let's add this definition so we can try out the next step of this. Main, what's this? Fingerprint, we're gonna do hello function. How do they do this? Just do lean? Oh, because it you gotta append the space. Crazy comment. Okay. Not 1,000% sure why it's on two different lines. Maybe it's like, oh, okay, yeah. Just gotta think. All right. So next. So there are a variety of ways to define functions in Lean. Simplest is to place the function's argument for the types of variable spaces. So definition of the function add one um, with elements in and the natural numbers. Fine, that's a natural number. I forgot why you have to do this. I forgot why you have to do that. Why do I have to do that? So maybe this one's defining the inputs. This one defines the output. Let me try it. So what happens if I take one of these? That's away. Found. Your guess is as good as mine, people. Your guess is as good as mine. Let me put it back and see if that makes any type of difference. None whatsoever. So yeah, I guess we're just gonna have to figure that one out as we go along. Yeah, I got no. I'm not even gonna Try to guess the explanation here. Okay, all right. This might be stating. Make it an integer? Is that a thing? Let me try that out. So what if I, wait a second, that work? Yes, it still works. Nice. So I can't subtract one. Okay, okay, okay. Yeah, I think that's what's going on. So I think this first one, let me go back to this example. I think these first ones are telling you the type of the input, while this last one is telling you the type of the output. Which one is ours? I don't fucking know. I think it's this one. But two M's just so I could tell which one's which. Okay, I don't think it mattered. Maximum. Maximum takes two arguments. 5, 4, 5. You can see the function's type by putting it in parentheses. So it takes a natural number, spits out an integer. Nice, nice. All right, so that's what it was saying earlier when we had the string to string because it already had one input, so it knew that one, but it needed another input before it could give you output for it. So let's do some of these exercises. So the first function, join with string, takes three arguments, outputs a string. So how are we gonna do? Now I solved it before, but I don't remember how I did it. So now I'm a little embarrassed, basically. Oh, boom, just like that, just like the space between them. So we're gonna come here, join strings with is gonna take three arguments that are strings. Call it first type string, second, it's also gonna be type string, third, it's also gonna be string. And then as an output, I want another string. So what was again? We wanted to switch. Want to switch the first and second one. The third stays the same. So we're gonna start from. I'm actually gonna do it from there. We're gonna give it the second argument or the third argument here. The first argument there. Then it should be the second argument. Let's see. Oh, let's see if we got it. Join with string. Oh, just like I said, first, second, third argument switches the two around. So what is the type? Let's figure that out. So join string width takes 3 strings, output string, just as expected. Now, I think this one was pretty easy. This one was pretty easy, but I got fucked up by a similar one that came after it. So a defined volume, so make sure that's not taken. The volume is gonna take a, which is max, let's say B, which is also a max outputs natural number. And we're gonna define that as a, I think multiplication list is B. I should have tried up with. Try that out. Let's see what happens. Should get 1. Function expected at B. Need to put in parentheses. Probably not, but let's try it out. Hmm. Hmm. See, this one's fucking me up. Okay, that part's good. What am I missing here? What am I missing here? They too close together? What just happened here? Oh, oh, this guy. Function expected to be. What happens if I put something else in it? Okay. Okay. So boom, we can define a function called string that is of type and is defined as string. Sure. So we're gonna try. Let's see if we can get that working. Oh, it's because I already have that defined as a setting. There we go. Okay, yeah, so that worked out. Did it work out? Did it work? It's NA to NA. Let me try their example. Should probably do that first every time, to be honest with you. So boom, got that. It's all good. Hold on. Might be me tripping. That might be me tripping. Oh, losing. Like we got something here. Same thing. I don't know. I'm not sure what's going on with that. It's the word. I just not allowed to use it. Celadon. Oh, not as already been declared. Okay, okay. I definitely can't use that one. Anybody using this? Let's try that one. Okay, we're back to sort of making sense. Oh, oh, the very next one. Literally the next example. Okay. So let me try this out. Do I have to put parentheses? I'm not sure. Let's try to not put parentheses first and see what happens. I think it'll work. No, not work. Students. Will not. Goddamn, let me try that then. Still need. Is it still? No, didn't need that info. Let's see this first. Still. Okay, so that works now. Oh, that solved it. See if I can do it without this other type on this side. And boom, that works. Out of there. right. So yeah, I think I'm gonna call it there. It was really interesting. So even after 3 months, I remembered a pretty good amount. I'm pretty embarrassed that I had to think about this at all, because looking back, like I literally just done something like it above here. Um, but yeah, hopefully you enjoyed that, learning a little bit more about lean, chapter one from subsection one to subsection three. Glad we got that all finished. And yeah, other than that, hope you liked it. Look out for more lean videos in the future. And yeah, I'll talk to you next time.